Okay, we already explained the bucket wear design. Bucket wear design means like you have one separator, you are creating one small bucket, one leg longer, and you are creating another wear, and you are getting fluid flow here like this. Okay, oil, water, oil plus emulsion. Okay, uh, so because in next stage oil and emulsion when you are getting, you will be separating separately oil and water, and will be treating emulsion separately. Okay, so initially when you are separating high pressure stage, so there maybe you will not be putting your heater treater and other equipment, so you will be taking 3 phases separately. Then you got oil, oil will have lots of water particle forming emulsion, so in that case you have to separate that one properly, okay, with different techniques. Okay, now height of water wear controls the liquid level. Okay, so this water wear height like A, B, C, D. So this A, B height will be controlling the liquid level. Okay, oil and water wear height difference controls oil pad thickness. Okay, so this oil and water level where this one, this height, okay, this height controls the oil pad thickness. Controls the oil pad thickness. Later we will try to derive some formula for this del H calculation. Water wear height should be below the oil water height. Okay, so water wear height should be PQ. So PQ should be below, the Q point should be lower than A point. Okay, so PQ, maybe I can write A, B, K, just some term I am giving, A, B, C, D symbol. Okay, A, PQ should be lower than AK. Okay, PQ is water wear height and oil wear height. Water wear height should be lower than water height. Water wear height should be lower than the oil wear height. Okay. Again, we have seen that BC should be lower than the interface height. DC should be longer than AB. Oil pad height del H equals H naught 1 minus rho naught rho W. Okay, this formula we will try to derive. So del H is equal to distance below the oil wear. First I will draw the figure. Okay, then oil water interface, and my water oil plus emulsion. Okay, then bucket we got oil out and water will be collected here. Okay, fine. So water you take out, sorry, water. Okay, I am not drawing whole separator, rather I am drawing only the wear part. So this is HW, this is HO, del H, this is HO, this distance is HW dash. Okay, so this is like, you can assume this is a separator. This is separated, this inlet diverter is there, so I am not drawing other part. Okay, so I am erasing this part. Now del H unit, del H is the distance between distance distance below the oil wear in inch. HO oil pad thickness, desired oil pad height, desired okay. This is also inch. So every time I'll write unit also, so that you should not get confused. Sometimes we write unit mixed up. For example, DLF and previous class we discussed separator sizing. Their inch and feet was multiplied. Okay. So here all are in inch. Rho W is oil density, oil density. Unit is lb per ft cube, and so this is not required. Then rho W is water density, lb per cubic feet. Okay. Now how to derive it? If you see, let's assume point A, another point here I am assuming B. Not here, here B. Okay. So at point, what is the pressure? H rho G, H water, rho water, H water W, H W rho water, G I can write plus oil height, H oil, rho oil, and G constant, so fixed for all oil or gas. Okay. Left side should be equal to right side. So right side H W dash rho W G. So all G will be cancelled out. So finally you are getting rho W H W plus rho W H O rho O equals H W dash rho W. Okay. So you are getting this equation 1. Okay. Now we can calculate H W minus H W dash equals minus H O rho O divided by rho W. Okay. Or okay. So you are getting equation 2. Now del H equals, from the figure you can see, del H equals H W plus H O minus H W dash. Okay. From figure you can see. Now from equation 2 and 3, if we replace H W and H W dash, okay, so just I'll rewrite this del H one, H O plus H W minus H W dash. Okay. Equation 2 and 3 implies 3 I'll put here, del H equals H W plus H W dash from 2 if we replace, so it will be minus H O rho W. Okay. Now H O common, so 1 minus rho O by rho W. So this is the derivation of the equation. Okay. Okay, fine. Now derivation done. Next, for the next one. Okay, I try to create one problem. Show you. So if I want to create one problem using that derivation of del H, so let's say assume rho O equals 0.97 oil density and water density is 1, oil pad height is 50 inch, then what will be the difference of water wear and oil wear? So just basically use the simple formula del is equals H naught 1 minus rho O by rho W. So, if you use the data 50 into 1 minus 0.97 divided by 1 equals, you are getting 1.5 inch. Okay. So, just I created a very simple problem so that you can remember. Now, another topic is level controller. Already we explained, but there are different types of level controller. I will show here using one vertical separator. Okay, you have inlet diverter, then you have maybe oil layer, water, oil, and you have gas out. So, in that case, you have one floating device, level controller, then oil out dump valve is going this like this. Okay, this is simplest design. Again, for water also you will have similar sort of level controller, dump valve. Okay, so water going out. So, this is normal simple interface level controller. Okay. Now, you have interface control with oil chamber. So, you create one oil chamber. Okay. Already we explained, but again this is oil you are collecting, but here you will have one level controller, you are getting oil out. Okay. So, water also you are getting like with level controller. Okay. So, this is a interface level controller, interface or normal level control also there, LC, and this one with wear or oil chamber. Another is that water leg with or without oil chamber. So, how this water leg working? So, in this case you will have separate one pipe, you have oil controller, you have water, but what are you taking out? You are creating another chamber, gas will be equalizing, gas equalizer, okay, and water will be spread here, and you have LC here. So, you are creating separate complex, more complex system, but you will have more control because you can change the length of this spreader. Okay, you change length change possible, or length or height. Okay, and so again you are putting level controller, LC here. Okay, so this way you are creating, this is called water leg. So, separately you are creating another leg, water leg with or without oil chamber. Okay. So, different other type of also possible, again electronic control system also there, so you can use, but you should know different options also, like what are the different possible combinations. Again there will be lots of innovations also. If you search patents and other document, you will find new ideas, new documentation. In oil and gas industry, basically they are depending on patents, innovation. Academic research will be lower, academic research will be following them, but in other industries many times academic research will be first starting point, then other industry will be taking up, they will be implementing. But oil industry normally, if you search any document, normally you will find patent, industrial product, then academic papers, because academics are not ahead of industry in this case. But if you say aerospace or other industry, you will get too many academic papers. So, academic research will be translated into industry, industrial product. But in this case, it is happening like industry is doing something, then academic people will do some research, they will be setting level, control, pressure or the other part. Okay, 5 minutes I will take. So, vessel internal, already we discussed separator. Separator vessel will have wave breaker, right. In two phase separator, whatever fittings or things we discuss, the same thing will be applicable here also. You may have more systems here in 3-phase separator than 2-phase separator. Okay. So, wave breaker will be there, mist extractor will be there, vortex breaker will be there. Okay. So, these details discussion will be there in previous lectures. Then downcomer, spreader, inlet diverter. Okay, then maybe heater treating equipment will be there. Maybe electrostatic separation system will be there, electrostatic system, right? Electrostatic. So, many internal components will be there, gradually we will learning. So, already we know something, but whenever we are discussing further, for example, electrostatic separation system, heater treating system and other systems, we will see much more complex system. Presently, we are discussing simpler one actually. Water droplet size, normally 500 microns will be their size, micron. Okay. And whenever we start calculating, initially it will be 2-phase separation, liquid and gas, gravity settlement. So, when liquid and gas settlement we are considering, normally we will be considering this 100 around micron particle size, liquid particle will be 100 micron. But when we are separating oil and water, 3-phase we are saying, like oil water also separation will be there. So, in that case, like water droplet size will be 500 micrometer or micron. So, similarly water droplet size also will be there. Okay. So, there will be retention time normally 3 to 30 minute. Okay. And high viscosity fluid or heavy oil like API 10. Okay. So, in that case viscosity high, so fluid particle will not get separate quickly. So, you need more retention time, but if thinner oil, light oil, so in that case separation will be quicker. Okay. So, in this case this retention time will be lower. Okay. So, in exam I can give, okay, if I give API viscosity, based on the retention time I can give some randomly. So, you can actually identify which retention time will be for which separator system, which oil. Okay. Thank you very much. So, next day we will discuss about gas separator, 2-phase, 3-phase separation, mathematical calculation, some example problems also. Okay. Thank you very much.